All right, today we're not going to clown around with compound inequalities. Let me get this all hooked up and we'll be ready to roll. All right, so compound inequality consists of two distinct inequalities joined by the word and or. All right, now I kind of like to say these involve an and. It's called an and sandwich. Okay, because it actually has the word and in it, and it's food. I mean, really, it's friggin' food. All right, so let's look right here. Here's the variable we want by itself. All right, I've got to get rid of this -4. To do such, I'm going to have to add 4. Not just here, not just here, but also here. That's it. All right, now, when we're done, these go away. This becomes 1. The sign stays the same because I didn't multiply or divide by negative. And this becomes 3. All right, so if we were to graph this one's not that bad. We got 1, 2, and 3. So this is a closed circle here and an open circle here. Now, this is also why I call these an and sandwich, because for those that shade up and above like this, that's the way it shades. Or if you shade on here, it's in the middle like a sandwich. Amazing. All right, let's move on to right here. There's my variable. So I need to get rid of I need to look what's being done. All right, so I see that I've got to subtract 4 and it's being multiplied by 3. So I've got to do those opposite. So I've got to add 4 to everything. All right, then I get 2 less than 3y less than 18. All right, now I got to divide now. Lottie-dottie, everybody. We likes to potty. We don't call it no. So when we divide, well, this is just 2/3, which is greater than y, which is less than 6. Now, if you're graphing this, this is how easy this is to graph. This is why people love me. That's how you graph 2/3. Now, a number between there is like 3. All right. No lines up underneath them. Open circle, and right there. Now, again, it's kind of shaded like that also. Okay. Not too bad. Could be worse. All right. So let's look at these. Just a couple more problems. Now, for those that have a fear of clowns, well, now you have clowns and math. So scary. All right, so I subtracted 7, everything, and I'm done. All right, so when I graph it, -5 is right here, 3 is right here, 0 is somewhere in between there. That's a 0, believe it or not. Open circle, closed circle, and everything in between, because it's a sandwich. All right, moving on right here. I look, I see what I have to do first. I know I'm going to have to add 5, add 5, add 5, add 5. Okay. Now, something else you probably should have noticed, and people may not notice till you get to this step right here. The bigger number is on this side over here. And all the inequalities are opening up this way. We hadn't had one like that. There's a reason why. This is a -2. When I divide by -2, I have to flip those signs. Okay, That's it. So -10, -4, something in between there. We'll say -7. That's right in the middle. All right, this gets a closed circle. This gets an open circle and a sandwich. I love sandwiches, by the way. I feel like Joey Tribbiani sometimes. I love sandwiches just as much as he did. All right. Now, these have ors, okay? These we treat a little bit differently. All right. Unlike the and sandwiches, where we can do everything all at the same time, it's really nice. These are not like those, okay? Because Mr. Jeffries gets confused, and I'm freaking wearing a rainbow wig, okay? It's not, I mean, I'm different. So I like to try to draw a little barrier right here so I don't get confused. All right, I'm going to work this one over here. So I'm going to subtract 2, 3x is greater than 6. Now I got to divide by 3, divide by 3, divide by 3. All right, excuse me. And I get x is greater than 2. All right, that's that one side. Now we got to do the other side, okay? Or this way. Yeah, I forget. It's opposite than the camera. Now, so over here, all I have to do is subtract 5. X less than -4. Now, the way you would write this is separately. I would graph this first before I would write it because I'm a visual person. Okay, I want to have 2 right here. I want to have -4 right here, and I'm going to put 0 somewhere right there. All right, if we look at this one, x is greater than 2. That's an open circle, and all the things greater go that way. This is x is less than -4, so that's an open circle going this way. Okay, so I would kind of write this as x less than -4 or x is greater than 2. Ta-da! Send in the clowns. All right. So right here, I'm going to subtract 2, subtract 2. 3x is less than -9. Divide by 3, divide by 3. X is less than -3. Now, my answer is a negative. I don't flip my sign because I didn't multiply or divide by a negative. Over here, though, it's going to be a little bit different. I am going to have to divide by a negative. So I get x is greater than -7/4. All right. Believe it or not, as a fraction, that's really close to -2, just not -2. All right. So if I was graphing this, and for this one, I would just put a big or right here in the middle because they're on the correct side. But if I was graphing this, which I am, -3, I'm going to put -2 right here. And I'm going to say that this is -7/4 because it doesn't matter how close it is if I say that's what it is. Okay, that's kind of how it works on graphs. Open circle. Open circle. I kind of like these. I was trying to find a picture because, you know, I grew up on Looney Tunes and they would say, which way did he go? Which way did he go? And Bugs Bunny would go, he went that way. And he would cross his arms and Elmer Fudd would be like, I don't know which way to go. So it's kind of, you know, they go away from each other. Okay. And together or opposite. And together or opposite. Okay. I'm going to kind of let y'all do this on your own because I got to make the main thing and move on. All right. Now, this is stuff that's new to Algebra 1 this semester, this year. Okay. This is absolute value inequality. We already have absolute value equations. Now I have inequalities. They're very similar. This is also a compound inequality. Now, it's going to, these, I actually had to remind myself as I'm scratching my head, this wig is itchy. Okay. Please remind yourself that there are two problems still. Okay. You're going to have one that looks very similar. And the second one, not only you flip the inequality signs and you multiply whatever is right here by -1. Now, this is what makes it an and. And I had to solve these to make sure. So I'm going to divide by 4 on both of them. All right, so I get x is less than or equal to 2, and x is greater than or equal to -2. All right, that still doesn't make sense until you graph it. So they're both closed circles. And this goes in the middle. All right, now the way you would actually write this, and see, this is why I would want you to graph this first, and I would tell you this if we were face to face, though I don't think you really want to see this all the time anyway, so some of y'all are safe. That's actually how I'd write this, just like this, because I would do the graph first. Okay, I'm a graph type person. Okay, very visual. Now, this one right here, very similar. Okay, we're going to have one problem that looks like what we have right here. Then we're going to have another one that still has everything in an absolute value. Y'all can't see, but I'm pointing at the screen that I'm writing. I'm very intense this morning. Okay, and I flip this and also do -5. All right, so I just subtract. Okay, so I have x is less than 2 and x is greater than -8. So again, graph it, graph it, graph it, graph it, because it makes more sense. Here's -8, here's 2. I'm just going to put 0 out here because I can. Okay, open circles and shade up and over. So this as an inequality, oh, I don't need to write the x first. This is -8 less than x less than 2. Okay, that's how that's read. All right. Again, I didn't know that these were ands until I actually solved them and did the graph. It's been a while since I've done these, a couple of years. So, all right. Let you do this one on your own. You know, extra practice. Everybody needs a little extra practice. All right. Now, these are supposed to be an or, and, you know, cat's out of the bag. If I didn't know the ands, how am I supposed to know the ors? All right, we solve them the same way. There's one just like this. The second one, we have the absolute value. We flip the inequality, multiply this by -1. Solve them, multiply by 6 on both sides to everything. Okay, so I have x is greater than 30 or x is less than -30. Okay, again, it makes more sense of the or when we graph it. Please don't tell me that the numbers go like positive all the way down the negative. No, we're virtual. Google a number line if you have to. Okay. All right, these are both open circles. Pew, pew. So it goes this way. So we're going to say x is less than -30 or x is greater than 30. What this means is we can choose any number in that range and plug it in, and we're going to get a true statement. Okay. All right. We're going to try this one right quick. So we're going to have a 2x is greater than 10. And 2x is less than, or I forgot to say equal to a while ago, -10. And we're going to divide both sides by 2. All right. So x is greater than or equal to 5. X is less than or equal to -5. All right. So on the number line, -5, zeros right here. Now these have closed circles and a closed circle up and over. Okay, so this would be x is less than or equal to -5, or x is greater than or equal to 5. All right, now there's another problem. Again, I kind of want it to be like a unofficial your turn. There's no more than that, but it's just an extra problem just to kind of play with, and I think y'all do great. Remember, don't clown around.